Site and context modeling for design and analysis. So in this video we are going to cover a few initial steps and preparation tasks really to get us underway modeling our site in Revit. So this is what we're going to cover: making a new file and setting up, importing an image or a map reference, scaling the image reference, and defining view ranges and levels. So this is really the sort of initial setup tasks that we need to do just before we can start modeling. And as we go along, although these are the specific tasks that I want to cover, we will be looking in all of these tutorials at the general user interface and covering general kind of use of the software as we go along. I prefer to do it like this, where we're actually underway with a kind of design or a simulation task, rather than going through all of the different tools, all of the different settings, but without any kind of obvious purpose. Okay, so let's go into Revit. So I've just opened the application, and what you'll see when you open Revit is it takes you to this kind of a splash screen, and what it's offering you is some of your previous projects that you've had open, which is very useful. The nature of a BIM project does mean that in many cases you will always be working in the same file, and so you would simply click on this icon here and your recently opened file would open. But we're going to go right back to the beginning, and we're going to start over here with a new project. And we are asked for, do you want to use a template? And it's offering us a few options here, and you could create your own template. You could be loading in a template you've pre-made, or in an office environment loading in an office template. But for our purposes, we're just going to keep it very, very simple, and we'll hit an architectural template, and we will create a new project, and we'll click OK. Just give it a moment, and it will take us into a blank project. Okay, so here we are in the blank user interface, and we did in the previous week we did have a quick look at some of these different tabs, some of these different tools, just to get familiar. And as I say, as we go along, we'll be picking up more and more of the tools that you see on the screen, the shortcuts, and the different ways of operating in the software. So what we've got on the left here is our properties palette, and I've actually docked underneath that our project browser. Now, if you're a bit short on screen space, I find it quite useful to have these sort of docked underneath each other. If you have lots of screen space, then you could have these palettes undocked, and what I would commonly be doing is I would have, certainly in a practice situation, is I would have two screens, and my big screen would be my sort of drawing area, modeling area, and the smaller screen would be where I would put my palettes and my various toolbars, and that is incredibly useful. But having said that, you can operate perfectly well on a reasonable sort of screen. This is actually, what you're viewing here is my native laptop resolution, which is, I guess it's about 1600 pixels wide, sort of standard laptop nowadays. Now you can pull these tablets and undock them, as you see there. That sort of ghosting you're seeing is because I'm recording this session, and I guess my computer's graphics card and hardware is being a little bit stretched trying to operate Revit and the screencasting software at the same time, but you wouldn't normally expect to see that. If I just drag it over to the left, it should dock. So it's docked on the left, and I've dragged this project browser into that palette. If I just drag it off, you could obviously position that where you wanted, but I'm going to drag it back, put it over the top of that palette, and it will dock it as a tab in that palette, which I think given the amount of screen space we've got here, that's probably a good idea. So properties, very important when you have an item selected. Project browser, this is how you navigate through all the views in your project. And we just go in the screen. At the minute, we are in level 0, plan view, which you can see is highlighted over here in bold. And we've got another level, level 1. If I double click that, there's level 0, there's level 1. And of course there's nothing in it at the moment, so they look the same. If I go to elevations, by default Revit will create an east, north, south and west elevation. If I double click on that east elevation, there it is. Not sure why it's doing this. Why is it doing this funny sort of docking off the screen? Not sure about that. Anyway, just a few very useful shortcuts while we're in here. WT, which stands for Windows Tile, will tile any open windows that you have onto your screen so that you can view both at the same time or multiple at the same time. Obviously, the bigger the screen you have, the more windows you can actually use meaningfully. ZE stands for Zoom Extents, and that will zoom extents in the currently selected window. So if I click over elevation east, ZE, it zooms in that window. Okay. Another one I find very useful is ZA, Zoom All, and that will actually zoom extents in all of your windows, which is very useful. Okay, so maybe let's just introduce a few other tools before we get started. Yeah, that's what I was looking for. Under your View tab, under your User Interface, over on the right here, important button when if you start losing palettes. So if you can't find your project browser, for example, it's over here. You can switch it back on. So if you were to close that there by mistake, you can get it back over here. Also, keyboard shortcuts. Just open that, and this gives you the shortcut for any of the commands in Revit. And Revit comes with many of them preloaded. You can just gradually get familiar with these, and you can add your own. You can edit these. So you could change those if you want. To be honest, I think a lot of people just stick with the ones that come preloaded with Revit. You can search up here. I'll just search for zoom. Oops. So go back into that. Search for zoom. Then it will filter out, and you can see the ones that we use more commonly. And these ones I find really useful. ZO, zoom out. As we mentioned, ZA, zoom all to fit. ZE, which I always consider zoom extents. Zoom in region. You can use either of these, ZR or ZZ. I tend to use ZZ. Zoom the sheet, ZS. Zoom previous, ZP. So there are some good shortcuts in there. Okay, let's just come out of that. What I'll also show you is you do get little clues about what the shortcuts are, little sort of tips. So if I hover, for example, here over the move command, we see that it's in the bit of help that it's bringing up. It's showing me where it says move brackets MV that the shortcut is MV. So that's always worth having a look at there. Okay, so there's our empty file, and the next step is we need to bring in some map information so we can start making a model. Now, there are many ways of doing this, and if you were in a practice environment, you may well be importing a file which is from a, let's say for example, a laser scanned survey, which might be three-dimensional information already. You might be bringing in a file from your landscape architect, and that may also already have three-dimensional information. Your civil engineers may be providing you with that. So many ways, but we're going to just stick with something fairly simple and something which I think is more useful to you at the moment as students of architecture. And we're just going to look at bringing in some very basic 2D map information. So the map looks like this, and this is a map that I have downloaded from the mapping service Digimap, and what I'll do is in a separate video I will go through how you can access map information from Digimap. It's a service which is available to us at the University of Sheffield, and very powerful in terms of getting mapping information. You can also download 3D mapping information, but for the purposes of this tutorial I'm just going to go with a simple 2D map. Okay, so here's our map. May look familiar to you. It's the university campus. Just zoom in a bit there. There's our where are we? There's the Arts Tower on there. Okay. Students' Union over here. It's got all the building footprints on it. So that's going to be useful to us, and it's also got some contour information on it. Okay, which again is going to help us in terms of building our three-dimensional terrain. Okay. Okay, so just a few other things about the map here. One thing that I have done is just to crop this map so that we only bring in enough mapping information for the area that we want to model. Obviously you could model more and more of a city, but generally in terms of simulation for a particular building project, you're kind of interested in the area around it, maybe a kilometre or less than a kilometre in many cases. Thinking about which buildings are likely to be overshadowing your site. So if I just zoom in a touch here, so there's the Arts Tower, there's our site, and we've got a reasonable amount of context on that map. Now the other thing is to make sure that you've got the correct level information. Now if we just zoom in a bit, this is an Ordnance Survey map, which is a standard sort of UK type map, and what I'm looking for is we've got a spot height here, an elevation, 114 meters. We've got contours. I happen to know that these are 5 meter contours, so therefore This contour will be 115. This one here will be 110. And if we just confirm that, 110 there, 105, if we follow that 105 contour, then I've got another spot height here at 103, so that's correct because it's just below the 105 contour. So that's just worth bearing in mind. Now, as I say, if you were using a more sophisticated type of map, you might be bringing in three-dimensional contours already, which may make the process slightly quicker, but equally may make it slightly too complex for what you want to achieve. Okay, so let's go back into Revit, and here's our ground floor plan. And what I just want to do now is, bearing in mind that our site, go back to our site, was at about 100 meters above sea level, and because we're modeling that in a BIM environment, we want that to be accurate. So I just want to go back into Revit and make sure that we've got an appropriate floor plan set up at the right level so that we can actually see our site. Now, what I'll just show you, if I go back to our level 0 plan here, and let's have one of our elevations at the same time. Let's do WT, Windows Tile. You see that the levels we have at the moment are level 0, which is at 0 here. And we've got level 1 here, which is at 4,000 millimeters. Now, so 4,000 millimeters is 4 meters. So neither of those plans, those levels, are above our proposed site. So if I was to start bringing that map into any of these levels, it's going to be below our site. So what I'm going to do is make a new level which is much higher up, so that we can actually see what we're doing. Okay, so what we're looking to do is to create a new level in the model which is a bit more meaningful. So I'm just going to maximize our elevation view there, and if we go to the Architecture tab up here, and we go across, and we've got level. Places a level in a view, and as usual you get a bit of advice there. And levels are incredibly important in Revit, because as you start modeling, what you are commonly doing is you are fixing components, fixing three-dimensional elements to levels. So rather than, for example, making a wall and giving it a height, you may be fixing it to a level. And the huge benefit of that is, in the longer run, if your project was to change and your levels changed, the elements that you've created are parametrically linked to those levels, and so they will adapt with the levels rather than having to change every level, every component independently. Okay, so if we go up to the Architecture tab here, and we click on Create Level, and it prompts us to insert the start point for the level. And what you might notice also is, as I hover close to the beginning of our existing level, it gives me this dotted line, which is offering me a snap. So it will snap to the start point, it will snap to the end point, and I'm sure you're quite familiar with snaps, but generally I find in Revit they're quite intuitive. They generally do what you want. So I'm just going to click there. Didn't place that accurately for the moment. Drag across, and again it's offering to snap to the end point of that other level. So let's just click there. Okay. Now we're still in the level command. As soon as my computer catches up, it's still offering to create another level there. I think my computer's frozen. If we just hit escape, that will take you out of the command. As I say, my computer. Okay. So double hit escape there to come out of the command. My computer had slightly frozen there. So we've created a level. We didn't actually place it terribly accurately, but if we just click in the number, the elevation of that level, we can change that. And I'm going to change that to let's do that again. I'm going to change that to 140,000 millimeters, which is 140 meters. Just hit return on that. It will disappear off my screen. If I hit ZE, there is that level up there. Now, just a few things there. If you're wondering why I'm working with such huge numbers in millimeters, well, in the UK, all architectural design and pretty much all sort of structural engineering is conducted in millimeters, which on a building scale makes a lot of sense, but obviously when you're talking about such large distances as 140 meters, they do seem like very big numbers. But don't worry about that. I mean, obviously in Revit you can change the units, but generally we do work in millimeters. Now I'm going to hit ZZ to zoom into that level we've created. Now, the thing to bear in mind in Revit is Revit is primarily about modeling three-dimensional elements. Now, a level is obviously a part of that, but the actual annotation line of that level is just a graphic device. Now, it will appear on your drawings, but it's obviously not a three-dimensional element in your project. It's a kind of tool to help you out. Now, you can always change how that will look. You can click on that level, you can modify it, you can drag the end of it, depending on how you want that to look in your drawing. You can rename it, but I'm going to leave it at level 3. Okay, just hit ZE, zoom extents. There's our levels. I think I will just change the scale of this floor plan. I'll change that to 1:500 just to make it a bit clearer to see. Obviously that's purely a view parameter, it's not changing your model in any way. So there's our empty elevation, nothing in it yet, and because we created that level 3, Revit has automatically created us a floor plan over here. I've got nothing in that, but I'm just going to click on that level 3. Okay, there's our empty level 3, nothing in it. With that selected, I'm going to go to the properties, and we're talking about the properties of that level. So WT, Windows Tile, click in our level 3 and look at our properties. And what I'm interested in is just to check the view range, which is over here. The reason I want to check that is because in any plan view you can limit the extent of view. So in other words, how deep into that plan will you see, and if you don't get that right, it can be a little bit confusing because you perhaps don't see your model because the view is simply limiting that. So if we just have a look at that, let's edit that. So what it's telling us is that our top view is associated to level 3, okay, here, and it will show anything up to 2,300 millimeters above level 3. So that's okay. Our cut plane, where it's cutting through the model, is at 1,200 millimeters above level 3, and the bottom of our view is at 0 in relation to level 3, with a depth of 0 again in relation to level 3. Now I wouldn't worry too much at the moment about the difference between the bottom and the depth, but what I am going to do is just make this deeper so that we can see further into our model. And in fact, I'm just going to set that at level 0, and I'm going to set the bottom of the view also at level 0, so that we now will be seeing everything from level 3 all the way down to level 0. Just click on apply and OK. So we can't, there's nothing obviously changed there at the moment. Now I'm just going to save this file. Save is under the top left, the Revit button. So let's just save that, so that, just in case it crashes. And I'll just put that on my desktop for now. Okay, just save that. Just give that a moment. Okay, so that's saved. We've not got anything in yet. We've got these 4 windows open. Let's have a bit of a clean up here. What you can find in Revit, every time you open a new window, it will keep it open. It may be hidden away in the background. There is a useful tool up here which is called Close Hidden Windows, and that will close, sorry, that's just at the top there, any windows that you're not currently using, it will close. Now at the minute all of ours are in use, but if we just maximize this one, our level 3, then no, thought it would offer me close, there we are, close hidden windows. Okay, just a slight delay on that there. If I click on that, it will close all those windows that were in the background. So if I now use the shortcut WT Windows Tile, nothing happens because it's just closed those down. Just something to bear in mind, because if you end up with 20 windows open, your computer might slow down a bit. Right. Let's bring that map information into our level 3. Okay, so we need to go into our Insert toolbar here. And under that Insert toolbar, you can see there are many things you can insert. Revit, CAD, DWF, Point Cloud, CAD, GBMXL, lots and lots of things you can import into Revit. Now I'm not going to go through all of those. You get into a lot of complexity there. What we are going to do is simply insert this image file. Okay, let's click on Insert, and it's now asking me to find that image. Okay, which, bear with me a second because it's hidden deep away in my file structure here. Okay, so that's the one we want to bring in. It's JPEG. Bring that in, Street View, hit open. Just give Revit a moment. I think Revit is slightly slowed down because I've got the screencast software running at the same time. Okay, left click, it's asking me to place raster image. So I just zoom out a bit there, just zooming with the scroll wheel on the mouse there. So it's just telling me where do you want me to place it. Well, I'm just going to drop it in the middle there for now, doesn't really matter. There's my map, ZE, zoom extents. So there's my map that I've brought in. If I hover over it, as you see, it will highlight the border in blue. If I click on it, it will put this sort of cross over the image just to let me know that I've got it selected. I can then drag it about, move it, just as as you would expect. Okay, so we've got a base map in, but is it the right size? Well, we'll just check that. I've deliberately brought this in the wrong size so we can just scale an object. Normally you find if you when you download one of the maps from Digimaps and bring it in, it will actually come in at the right size, but let's just go through that process. So ZZ, zoom in here, and I've brought in a scale bar on the map, which is very helpful because you can just check if things are the right scale. So a few things you can do here. You could draw a line along that scale bar to measure it. I'm just going to actually use the measure tool, which is always docked on the top here. It's quite a useful one. Click on that, and it's asking me to click to enter the first point. I'll just zoom in a touch there. Okay, starts measuring. Go across to the end here and click. Okay, and there is my measure. It's a bit hard to read that, but it's measuring at 41589. Okay, which we'll just call 41500, which is accurate enough for our purposes here. So in other words, 41.5 meters we're scaling off. And when we look at our scale bar, that should be 100 meters. So as I say, our map that we brought in is actually slightly the wrong size. So we've tested that, and we just need to verify that. We just need to scale it to get it right, basically. So I'm just going to hit ZE, zoom extents. And in order to select this, you notice my cursor has changed because I'm still in the measure command. So escape twice will get me out of that command. Or if you click on the modify command up here in the top left, that will also take you out of a command. Okay, click on our image and let's just use the scale tool, which is up here. Now, I don't know if you remember last week, I did point out that what happens in Revit is the toolbars do change depending on what you've got selected. So I just went back a step there. I was in the Insert tab, and it's giving me all the options for inserting, but as soon as I click on my map, that automatically takes me into the Modify tab, and that's because Revit kind of intuitively thinks that because I've selected an object, I probably want to do something with it. I might want to copy it or move it or scale it. And I found when I first started using Revit, this was a bit confusing, but it does start to work very nicely for you, I found. Okay, so there's our map selected. We've got this scale button here, scale tool. Click on that, and you see my cursor has slightly changed, and it's wanting me to specify the center point of the scale. I'm just going to click in the middle there, and it's offering now that I can scale it graphically by clicking points, but I'm actually going to come out of that and go up to here and change that to numerical. Graphic, you could do it graphically, that would be absolutely fine. I'll just do it numerically. So we need a scale factor here, and rather than getting my calculator out, I'll type an equals sign into there, and Revit can then perform a little calculation for me. So the distance that I wanted was 100,000 millimeters, or as it's a scale factor, it doesn't really matter, we'll do it 100 meters. And what I actually had measured off was 41.5 meters. So it will perform that scale factor, hit enter on that, which is about 2.4. And now it's prompting me again for the scaling point. Just click anywhere, I'm not too bothered there. So it has scaled it, and we'll just check that. ZZ, zoom in, and now let's just measure. I'm just going to do it roughly here. Quickly measure off there, and yeah, that's saying 100 meters. You see at the top left here, it's also giving us that dimension. Okay, I know it's I didn't do it very accurately. It's saying 100.6 meters, but you know, good enough. Bear in mind, you're talking about very large scale models here, and a few millimeters isn't really going to make any difference for our purposes. Okay, if you were using three-dimensional survey information, that would be more accurate. Right. So there's our raster image, ready to start modeling, and I'll save the file, and we'll just pause it there, and then the next video we'll start actually modeling some site information.